You can start now.
Good evening to one and all present here. On behalf of the organizing committee, it gives me immense pleasure to welcome you all to this sixth session of ATAL FDP, a platform envisioned to empower faculty members with emerging technologies and industrial relevant knowledge. We are delighted to see such enthusiastic participation from our respected faculty members. Your presence truly reflects your commitment towards continuous learning and academic excellency. Today's technical section focuses on highly relevant and future-oriented topic, AI application for solar energy forecasting. With the rapid integration of renewable energy into modern power system, accurate solar forecasting using artificial intelligence has become a cornerstone for efficient energy planning, grid stability, and sustainable development. This session promises to provide deep insights into how AI and machine learning are transforming the renewable energy landscapes. Now I call upon Dr. B. Pushpavanam sir to intro the speaker.
Thank you. Hello, am I audible?
Sir.
Good evening, everyone. It is my privilege to introduce our esteemed resource person for today's session. We are honored to have with us Dr. S. Kalyani, subject matter expert level 3 in the field of electrical engineering, L&T EduTech. Spanning experience of more than 22 years in her profession, she has gathered an invaluable expertise in both industrial and academic spheres. Dr. S. Kalyani completed her PhD in electrical engineering on a unified approach for power system security assessment using pattern classifiers from IIT Madras. She completed her post-graduation in power system engineering from Tyagarajar College of Engineering, Madurai, and undergraduation in electrical and electronics engineering from Alahappa Chettiar College of Engineering and Technology, Karaikudi. She has served as head of the department for 7 years and dean as 3 years during her academic career. Dr. Kalyani's focal areas of specializations include power system stability and security, renewable energy, artificial intelligence, machine learning, smart grid, and electrical vehicle technologies. Her distinguished career is profound with a rich research contribution exemplified by a publication track record of about 22 research papers in SCI journals, 17 articles in Scopus UGC indexed journals, and 54 conference presentations. Additionally, she has been granted with 2 patents and 3 copyrights and has published 2 book chapters, one in Wiley and another in Scriver Publication Company. 8 candidates have successfully completed PhD under her supervisorship, and I am the 8th candidate. In Anna University, Chennai, she has completed sanctioned projects in MODROBs, conferences, seminars, FDPs funded by the agencies like AICTE, DRDO, TNSCST, etc. She has won many awards and prizes for her academic proficiency during her graduation and profession. She is a recipient of Inspiring Research Supervisor Award from SEEE and Outstanding Faculty in Electrical Engineering from Venus International Foundation. She has completed a world record attempt by participating in 54-hour trainathon as a speaker and certified by Tamilian Book of Records and Asian World Record. She has completed 11 NPTEL courses in Enlight, out of which 2 courses she was the topper. She has acted as chief guest resource person in many conferences, seminars, FDPs, STTPs, and delivered invited talks. And her Google Scholar profile shows H index is 15 and with a citation count of more than 800. She is a life member of ISTE and IEI. So we are confident that her vast experience and practical exposure will provide valuable insight into the procedures and best practices for the industrial design filling in India. I now request Dr. S. Kalyani to kindly take over the session. Welcome, ma'am.
Yeah, very good evening to all the learned professors gathered over here. Hope my voice is audible.
Yes, ma'am.
Okay, so thank you very much. First of all, I would like to thank PSNA College Management, Principal and HOD of the department, and the coordinators, especially my research scholar, Mr. B. Pushpana, for giving me an opportunity to get connected with the learned professors across all the states in India. Because in online FTP, we can have participants from various states and even across the globe. So I feel privileged to be a part of this program. So I think this is the sixth session. Already you would have been listening to various sessions of various experts. You would have got a lot of insights related to AI and ML, machine learning techniques in the applications of electric vehicle and renewable energy systems. That's what the title of the FTP is also. I will today's my session will focus on AI applications with respect to solar energy forecasting. So currently I'm working in L&T EduTech for the past 2.5 years. Previously I was in academic profession only for 20 years and above at various cadres. So here in L&T EduTech, we are completely working on the field of renewable energy and electric vehicles. That is actually the course which is assigned to me. We are involved into the design of solar PV system for residential buildings, commercial buildings, rooftop, ground mounted, all those things. So since my PhD was related to AI applications in 2007 itself, I started working in AI applications. I thought that to connect with this FTP, I can give some insights towards AI applications for solar energy forecasting. So let me share my screen. So I know that it's all tiresome. You're all undergoing the college hours or whatever it is, and beyond the college hours, you are sacrificing your family time and you're attending this FTP. For appreciations for that, first of all. So, how to minimize? This will not minimize.
Just close it, ma'am.
Uh, okay.
Yes, ma'am.
Okay. Is it fine? Is my
Fine,
screen
ma'am.
visible?
Fine, ma'am.
Okay, okay. Thank you very much. So, intermediate, if you have any doubts or queries, please put it in the chat box and somebody can help me to read the chat box messages then and there. You can stop me, interrupt me, and read the chat box messages because I am connected only through my laptop. I think somebody is there coordinating the session, right? Pushpona?
Sure, ma'am.
Okay, ma'am.
Okay, if anything is put it in the chat box now, you kindly let me know. Okay.
Sure, ma'am.
I hope that the audience are a mixture of, engineering faculty from various disciplines. Is it so? From electrical, all disciplines. I think we have participants. Is it so, sir?
Yes, ma'am. Yes.
Okay. So, because the audience is a mixture of audience, so I will first go into the basics of AI applications. All I think already you would have some expert would have covered, or already you have known about it. But quickly, let me review the basics of AI before going into the actual case study, that is AI application for solar energy forecasting. So the content will go like this. Let me introduce you to AI and ML. Then let me introduce you to the concept of solar power forecasting and how AI is relevant to solar power forecasting and what are the various algorithms. Of course, now numerous algorithms have come up with respect to AI and ML, like deep learning or LSTM, CNN, everything. But there are some very common AI ML algorithms which are frequently used in various applications. Let me touch upon it. See, I'm just going to give you an overview, an idea. So, if you are really interested, you can explore more and you can even get connected with me beyond this session. I will be ready to help you clarify your doubts or any, if you're involved in research work, definitely in the field of AI and ML, I can help you to my level best. Okay. So the content will go like this. Then we will describe about the algorithms, then performance metrics. Then finally, I will touch upon the simulation results which we have developed in MATLAB for a set of data set which we have, taken from the real-time plant. Okay. Now, first, what is AI? So, I think you all have known. Okay, so artificial intelligence. So, we are going to create the intelligent artificially. So, we are going to simulate the human intelligence, and we are going to create a mission which will be working like human. Of course. AI can never replace HI. First, we have to understand. Okay, so AI can only supplement or aid the performance. Okay, or it can reduce the manual work, no, the continuous repeated manual work which is being done by the human, that is reduced to some level, so that the human work will be more and more productive if they are using AI as a tool for their various daily routines. Okay, that is where AI stands. And formally, if you want to define AI is basically a branch of computer science. It comes under the branch of computer science, and it is going to make we are going to make the machines programmable in such a way that it can think and act like humans. So examples of AI, if you think, many examples are there. One of the example I have quoted is speech recognition. Okay, so you could remember that. Suppose if your friend is calling you after 10 years, okay, for the past 10 years you do not have any contact, suddenly she gets your number, she or he gets your number, and they call you. So you feel so happy immediately. When you pick up the phone, you tell, hello, hey, you are the guy, where are you, like that, are you, how are you, like that. Immediately we are able to recognize, they are, just by listening to their voice we are able to recognize so and so is the person. How that is possible? Because in our brain it has been programmed. We have got that past data, we have conversed with her so many times before that we could register her voice in our brain. Okay, so it's similar to that, right? So AI can be used for such speech recognition. Just by hearing a voice we can tell whose voice is it. Okay, and for a variety of problem solving applications across all domains, not only in the field of engineering, I would say that AI has more applications in medical field, where we come up with patients with different types of what to say, the when we take the test reports, no, it's having a lot of variance. Okay, so we come up with that, so we can identify the disease of the person just by using the AI technology. Okay, and we have to give the past data. Okay, so what is the main crux of AI is, we have to feed the data, AI model with large vast amounts of data. Okay, and if the data is not properly collected and given, then the AI model will not be a successful model. So the entire success of the AI model depends upon the data which is generated and fed to the model. This is very important. We should understand. Okay, and the data should cover the whole spectrum of operating conditions. That means if I tell that if I want to do the AI model for solar energy forecasting, I should include all the possible scenarios which will occur. Okay, whatever the possible worst cases, scenarios that may have happen with respect to climatic conditions, with respect to some shading effects in the plant. So all such scenarios I have to take into account, and I have to create a data set. That means then the AI model will be more generalized model. Okay, AI or ML or whatever you talk about. And the AI or ML model, they are completely mathematical driven. They are called data driven models. The name itself is called data driven models, and it is purely based on the mathematics. Okay, inside what happens is complete mathematics, and it is an iterative process. So AI, no, they are subjected to a lot of iterations. So we call it as epochs. We don't call the name iteration, we call it as epochs. So they are subjected to number of epochs through which they learn, and then they learn, relearn, and finally they come to a proper structure. Okay, so this is what is the idea of AI. Okay, so it will allow the software to learn automatically from the patterns, and the data will have a lot of patterns or features. What is meant by patterns or features? If you see any data sample, if you see, they will be having like rows and columns. Rows are nothing but the sample numbers. Okay, suppose if I tell my input data is 100 cross 10, 100 samples I have with 10 attributes. 10 attributes means one attribute is temperature, one is cloud coverage, one is maybe humidity, one may be wind direction, like that. I have multiple attributes. All these attributes are called patterns or features with respect to data. And initially, when AI was developed, any idea when AI came into existence? Uh, I mean, the evolved, when, in which period, in which year approximately AI started evolving? Any idea? Can you put it in the chat box? Anybody can put it, your query, I mean, your reply, and somebody can help me to read that reply. Let us make the session more interactive. Any responses? Hello. Any responses in the chat box? Hello.
Some responses are there, ma'am. 1997, 1956.
Okay,
Dr.
so
P.
good, good.
Yeah.
Yeah. So actually, if you see, the AI started evolving in 1980s onwards. Although the concept evolved in 1950, 60, it started evolving from 1980 onwards. Okay, so a lot of research articles have been published with respect to AI and its applications. So during that period, whenever we tell AI, the only thing is artificial neural network (ANN). ANN was the only network architecture which was available. Okay, so what is this ANN? ANN is basically like an intelligent controller. Okay, you can imagine this is your ANN. It will be having a lot of layers like input layer, hidden layer, and output layer, and it will be having the weights between the input layer and hidden layer. Will be having the weights. These weights are the ones which get updated during each iteration. Okay, so we'll be giving the input samples, and the it will be processed in the network. You will get an output, and you will be comparing the output with the target, and based on the error the weights will be adjusted. This is what is a process of training. Okay, and this training can happen offline or even online. Okay, offline means I'm giving a set of data to the model, I'm training the model, then I'm giving a set of data, I'm testing the model, that's all. The model is working fine, I'm putting it in the real time implementation. Okay, then any unseen new data is coming in, the model will give the prediction or classification for which it has been trained. That is called offline. That means the training will be done offline, right? In online, I am training the model with a set of data, the model gets trained, the model gets built. But in the online also, it is getting a lot of samples, new samples. So during the time it is getting new samples, now it again builds itself, it retrains or it relearns. Okay, example is ChatGPT is an example of online AI tool. Okay, what ChatGPT does, ChatGPT, whatever prompt we am giving, it learns every day, it learns, and every day it performance improves. That is what is an online training, and we expect online training only so that the system will become more robust and adaptable. Any system, we need to be self-adaptive and robust. Okay, so that is where the online training nowadays, all the AI models, we want it to be an online trained model. Okay, and this artificial neuron, okay, this basically they came from the biological neuron, we all know. So okay, so you can see what is a biological neuron, what is a neuron which is existing in our brain. Just people thought of the neuron structure, biological neuron structure, and they came up with the artificial neuron architecture. That is what is the analogy. So here we have the cell body, and we have the nucleus, and then we have the dendrites. Okay, and there are the impulses which is carried from one cell body to another cell body. Okay, so you can just imagine, suppose if you are touching a vessel which is very hot, assume that you are touching a vessel which is very hot. Immediately, what you will do, you will remove your hand. Otherwise, you feel that you are able to feel it. So when you are touching an object or a utensil which is very hot, immediately the signal goes to your brain, and the brain instructs you to remove your hand. How you are doing this? Nobody is coming and telling you to do it. Okay, because your neurons have been already programmed. Okay, from the childhood, from the day you were born, you are learning. Your neurons getting simulated day by day, it's getting updated day by day. Okay, that is what is happening. Okay, maybe in the childhood days, unknowingly you should have not, you will not have removed the hand also, you'd have even burnt your fingers. That's what the kids know. We always take care of the kids much cautiously. Okay, but as you grow up, you know what is right, what is wrong, what to be done, what action to be done. You need not have to rely on anybody. It's all because you keep learning. So the same concept is also applied for the artificial neuron. So here we have the axons. Axons are nothing but here we can see the data, no, the input signals, how the signals are through axon only it enters to a cell body. Similarly, here we call it as axon from a neuron, and we'll be having input neurons or whatever it is, hidden layer neurons, and these are the weighting. So here the layers are connected. Okay, so here these are the weights. Okay, so these weights are nothing but synapse. In biological neuron we call it as a synaptic connections. Okay, that is what is equivalent as weights. And this is the dendrite. Dendrite is the one which carries the information. Okay, weighted information. Okay, then in the cell body you do the algebraic sum of that, and then with the bias. Okay, bias is just to understand that a positive negative both things need to be compensated. Okay, then in the cell body you have an activation function based on which the output value will be evaluated. So this is how the artificial neuron is related with the biological neuron. Okay, so now we will see the structure. Okay, we will see the structure of the ANN. This is what is structure of the ANN. So you have input layer, you have hidden layer, and you have output layer. Okay, so hidden layer, if you see, there can be number of hidden layers. There is no restriction, and there is no restriction for number of neurons also in the hidden layer. Whereas the number of neurons in input layer should be equal to the number of input variables, and number of neurons in the output layer should be equal to the number of output variables. This is mandatory. Whereas in hidden layer, you can have as many neurons as possible. But if you have too many hidden layers and too many hidden neurons in each layer, the network architecture will become more and more complicated. Okay, so we cannot realize in hardware. When you want to realize in hardware, so any technique you are adopting ANN controller, but you want to realize in hardware, right, in the form of embedded system. So it is very difficult. So you have to make the network more simple as possible. You can reduce, that is, don't have more hidden layers. Maybe you can have one hidden layer is okay, two is okay, but more than two you think whether to have or not. And similarly the number of neurons also you can restrict. Okay, otherwise the network will become complicated. So inside this neuron, each of these neuron you'll be having activation function. Okay, so you cannot have different activation function in each of these neurons. If you take H1 layer, all the neurons in the H1 layer will be having the same activation function. Okay, so you cannot have this tan sigmoid. This one is a hard limb. That like that you cannot vary. That is not possible. Okay, so this is how the network architecture is. And here, if you see in the input layer, normally the activation function is called pure len. Here you can see the activation functions. Pure len activation function, that is linear function. So what the input neuron does, it just passes the signal to the next layer. It doesn't do much calculation. It just passes the signal. Here only all the evaluations happen with respect to the function, whether we are using tan sigmoid, log sigmoid, or radial basis, whatever it is. And similarly, output is also like a pure line function. It also takes the value, whatever it is there, and gives us an output. If it is a classification problem, the output is 0 and 1. It's a binary logic. So there, instead of pure lim, we can use hard lim, so that it will hit the value to either 1 or 0. So this is what is the complete working of a ANN architecture. Okay. So any doubts after this? Are you able to follow? Any doubts? Can I, can I proceed further?
Yes, ma'am. Yes, ma'am.
So under the umbrella of AI, we are having a lot of techniques like machine learning, speech recognition, computer vision, language processing, natural language processing. So what we call now the ChatGPT. ChatGPT is basically a language processing model. Okay, it's a LLM model, that is large language model. Okay, and there the data analytics will be much more. Okay, it is handling huge voluminous number of data, because of which only its performance is good. Okay, then expert systems like fuzzy logic or optimization techniques like meta heuristic. So all this comes under the umbrella of AI. Okay, and if you take machine learning as one major component of AI, which is widely used in many applications. So machine learning was developed by a person called Simon. Okay, what is learning? Learning is improving your performance by experience. Machine learning is also the same thing. Here we have computer programs which are already programmed by human being. So that programs know they improve their performance through the experience. That is through the past data. That is what is known as machine learning. Okay, and what is the idea of learning an ML system? So here you have three important things: task, performance, and experience. Okay, so experience is the past data, and you are using the past data and you are improving over the task. For example, yesterday I committed a mistake. Okay, unknowingly blunder mistake I committed, maybe in the work or somewhere. Okay, in the home. Will I repeat the same mistake today? No, because yesterday I have learning from mistakes. Okay, so I will now improve my task. Okay, so I will not commit the same mistake. So as a result, my efficiency will be better. That is what. Okay, so learn from the experience, improve the task with respect to a performance measure. Have some performance measure. So I have written internal assessment 1, I did not perform well, I will not do the same thing in assessment 2, I will improve. Okay, so my measure is what? Marks or score is my measure, right? So example, if you take swamp filtering, you can take email filtering example. So this is especially applicable for call centers, okay, where they'll be having huge number of mails hitting their inbox. Nowadays, if you see, even for us, even for our profession, just 1 hour you don't see the mail, you can see about 20 or 30 inbox. Your inbox will be filled. So you don't know which mail to read, or which mail is important or which mail is not important. Okay, so every mail you cannot keep on reading, right? So what you have to do, you can filter your emails. So you can have an AI model nowadays that is already built in inside the Microsoft Outlook and all. So you can have an AI model and you can select if this is the center, you don't put it in the inbox, put it in the swamp, like that you can filter it. Okay, so you can filter based on many parameters or many attributes. You can filter it either as a the swamp email, or a main email which is to be put in the inbox. So here the task is you have to identify whether the mail is a swamp or non-swamp. Performance is what you are classifying, right? You are classifying as a swamp or non-swamp. So how many data you are giving, how many it is correctly classifying, you are finding the accuracy. So accuracy is the number of percentage of emails that is correctly filtered. That is only called as the performance. And E is experience. E is what? Database of emails that is being given, that is being built by the users. So you are giving a database of emails. That is what is E. So any AI or ML model, if you take, these are the steps involved. First thing is you have to collect the data. Okay, necessary data you have to collect. After collecting the necessary data through sensors, through some real-time world data set, through any means, through experiments, by any means, or benchmark data set is there. So you collect the data. Once you collect the data, you process the data. That is a technique called data mining. So in computer science, you will have a separate course called data mining, where handling the data is a major thing. Okay, so I told that the success of AI model relies only on the data. If the data is not proper, AI model will not be successful. So you have to clean the data, you have to properly clean it. Okay, you have to pre-process, you have to bring it to a uniform scale. For example, you have temperature 20 degree to 100 degree, whereas your current value is 1 ampere to 3 ampere. So current is a 1 digit number, temperature is a 2 digit number. So AI model will not know that that is temperature and this is current. Okay, it will treat all the data as a numerical data. So you have to normalize. It's better to normalize and bring to a normal scale, 0 to 1 or -1 to 1. That is what is pre-processing. Then if you need, you can go for dimensionality reduction. So generally the models are n dimension problem depending upon the number of attributes. If you are having 10 attributes, it's a 10 dimension problem. So if you are having 10 attributes, when you go for real time, you have to have sensors for all these 10 attributes. But it is somewhat difficult. Okay, what we can do, we can reduce the number of attributes. So you can apply a technique called feature selection, where you can identify which are the most dominant features or attributes which will be used for classification or regression problem. Those features alone you can take. So instead of having 10 attributes, if the dimensionality reduction gives you only 5 are important, that 5 alone you can take and you can proceed. Okay, Clear. So this is what is dimensionality reduction. So a 10-dimensional problem is reduced to a 5-dimensional problem. Once the dimensionality reduction is done, you go for model learning. So you build the model, you train the model, the iteration process, everything continues, and finally you get the model built. Once the model is built and trained well, you have to subject for testing and validation. So this is what is a complete block diagram for any AML algorithm, irrespective of whatever may be the application. So for the email filtering example, if you see, this measuring device is nothing but your server. Email, the server is there, no, where all emails will be stored. The server itself can be given as a input, and features can be like number of recipients, size of the message in terms of kilobytes, number of attachments, number of CCs in the mail. So like that, some examples I'm giving, like that you can add anything. Okay. Now, under machine learning, we have different algorithms like supervised, unsupervised, reinforced, deep learning, and deep reinforcement learning. So, this deep learning is recently we are using deep learning. It is an advanced version of ANN. So, ANN disadvantage of ANN is its generalization ability is very poor. Okay, but deep learning is able to overcome the problem, and it is able to handle even more complex patterns. Okay, because it has multiple layers. So that is what is the advantage of deep learning. And in supervised learning, we have two types, either classification. We can either use the ML model or AI model for classification. Classification means binary or multi-label classification. For example, if you give the data, you can tell whether the patient is having the disease or not. That is classification. What is regression? Regression means forecasting, predicting. I want to know what is the solar plant output next year, what is the solar plant output tomorrow, day after tomorrow. So if I want to do some weather forecasting, load forecasting, power output forecasting, we have to go for regression model. Okay, so there are certain metrics which are unique for classification and regression, which need to be used when we evaluate the performance of the model. Okay. Unsupervised means clustering. So here you don't give any labeled data. You all the data are unlabeled. You don't know the output. You only know the input. Using that, you do the you apply the machine learning model. So basically, they are called clustering algorithms. Okay. So I'm just giving you the overview. I'm not going into the detail of each and everything. Now, why ML outperforms traditional methods? So traditional methods are all relying on the static models. They're all static. Okay, it's like a they are not subjected to varying conditions. Okay, so they are all static physical models. Whereas ML, they always we give the real world data sets. So they are highly dynamic. So they are adaptable. So this is one of the reason why we move for ML. And leaving the traditional. And another thing is the traditional approaches are highly time consuming. Okay, and with respect to solar energy forecasting, if you see, the input data itself is non-linear. We don't know about the weather effects and all. Okay, but when you go for ML, they will be able to handle such high non-linearity and high uncertainty, which can be handled in a very smooth way by lot of new networks are there. We can use the appropriate networks which will perform much better. It is not that this network is the best network. For every application, for on one application, decision tree will be best. For another application, the LSTM will be best. For another application, SVM will be best. So it all depends upon the data set which we give and the application which we focus on. Okay, and very important advantage is the generalization across the regions. That is, you develop a model. For example, you develop a model for solar energy forecasting. The real time plant you are taking, maybe the plant is located in Chennai. Okay, so you can apply the same model algorithm, the program for another solar plant which is located in maybe Rajasthan. Okay, so it is no need to change the algorithm and all. So that is what is a generalization. And having understood the basics of AI, let us quickly understand what is solar power forecasting. So, what is solar power forecasting? We want to predict what is the electricity that will be produced by the solar plant over a certain period of time. Okay, accordingly, we have different horizons. Depending upon the time horizons, we have very short term, medium term, and long term. But generally, very short term, we don't focus much. Maybe short term, okay, some level we focus, but medium term is very common, right? So this is 1 hour to 24 hours, that is day level forecasting. This is month level forecasting, and this is year, okay, in terms of Jan, February, like that, okay, 1 month to 1 year. So why this forecasting is needed? Because we need to plan for energy. The demand is increasing day by day. So if the solar power output is not going to the as expected in the next year or so, I have to plan for some alternatives, okay, because the solar output highly relies on the weather conditions. So I have to first take the meteorological data, I have to first do the weather forecasting, that using that only we can do, okay. So first what I will do is I will have the data which is already available. Maybe if I want to do the prediction for 2026, I will already have the data for the plan for 2024 and 2025. Okay, those data will be taken. The weather data is there. The input weather data, output solar output is there. So based on that, the model anticipates, no, maybe in the future what will be the weather forecast, what will be the weather, the humidity or the temperature or whatever you think of. Okay, so it's very important for proper grid management and maintenance, and also to ensure a stable and efficient power supply. So why we have to go for AML for solar power prediction? Because it handles a lot of non-linearity and complex patterns with respect to weather data, with respect to power generation and the environmental factors. And machine learning is of course widely used in the field of energy prediction, not only for solar but also for wind power forecasting. Now, most of the power generation is by renewable. You all know, as per the statistical data, if you take the data from the Central Electricity Authority, the data says that nearly 40 to 45% of the power generation is from renewable energy. Okay, currently, if you see, the installed capacity is around 420 gigawatts, which is expected to increase to 800 gigawatts in another 2 4 years. So the demand is going to be double. How we are going to compensate? Only through the renewable energy generation, because we cannot rely on thermal due to depletion of fossil fuels, and nuclear also, it's highly expensive, we cannot go for that. Okay, so the only source in India or any country for that matter is solar and wind. That is some dominant renewable energy thing. So we have to do some prediction analysis with respect to that. Okay, so machine learning models learn from the historical weather data or solar irradiation data and the power output data. So these are the various. So it is not only used for power forecasting. Okay, you can use the AI model in solar panels itself. You can optimize the tilt angle. So you are placing the solar panel. You are mounting the panel at a suitable angle above the ground. Normally, the tilt angle should be equal to the latitude of the location. That is the thumb rule. Okay. But you want to have a more optimal tilt angle. Okay. Then you can apply some AI models to analyze or to find what will be the appropriate tilt angle. Then fault reduction, cleaning schedules you can do with respect to AI. Similarly, in inverter, you can do AI. You can use AI for inverter failure detection. Then conversion efficiency also you can optimize in inverter. Okay, that is the, inverter is the one which is going to convert your DC to AC. So the conversion should be efficiency should be better. Okay, the amount of AC DC which is coming in should be equivalently converted into AC. So that also you can think of with respect to AI. Then you can adjust the tracking angles. If you go for instead of fixed panels, if you go for tracker based panels, where the panel will move according to the sun's direction. So that tracking angles also you can apply AI and you can use it more real time. Okay, and in charge controller you can enhance the battery charging strategies. The number of cycles, no, the batteries efficiency and lifespan purely relies on the charging and the discharging cycles, that you can enhance with the AI model. This will be not only used in solar but also in EV, electric vehicles. Okay, then AI can optimize the charge discharge cycles, that's what I told. Then AI can analyze the data for forecasting, that is what now we are going to do. Okay, so in every component, you have an AI application. It is not just for the overall output prediction alone. And when you take the this one, solar power forecasting, the power output of the solar is majorly influenced by irradiation. That we all know. Okay, So the major parameter or the attribute which influences the power output is your irradiation. And what is irradiation? Irradiation is the amount of power per unit area which is measured in watts per meter square. This is the amount of light intensity which is falling on the solar PV cells. Okay, that is the number of photons, how many photons it is able to absorb. Okay, so that is basically it tells about the efficiency of the panel. Okay, generally if you see the solar panel efficiency is only 30 to 40%. Even if you take tracker placed panels and all, it is not, still it is in the range of 30 to 40%. So 30 to 40% efficiency is not a good efficiency, right? When we take transformer, the transformer efficiency is 98%. When you take induction motor, its efficiency is 85%. When all the other things are having more than 80% efficiency, solar panel is having only 40%. So that means how much amount of light energy is intake, it is only 40% of it is converted into electricity. So people now they are working more on the material which is used in the solar cell. So in order to improve its efficiency, they are using dye sensitized solar cell and all. A lot of innovations are coming up in that particular matter. Okay, so this factors affecting irradiation. Irradiation depends on the geographical location. If you go for a sunny place, the irradiation will be more, like Rajasthan. Okay, then time and season. What is the time? Daytime, nighttime. Okay, then weather conditions. Like when suddenly there will be a cloud, it will be a sunny day, but suddenly a cloud comes. So always remember in solar, it is the not the rainy days which affects the output. Rainy days will never reduce the output. Only the cloudy days. Only when there is a cloud cover, the irradiation value reduces. Okay, and also it is affected by shading. There are some nearby trees, you are having it in rooftop, you'll be having trees, you'll be having nearby buildings, all that will reduce the radiation. Okay, okay, what are the key challenges in solar power prediction? If you see sudden cloud movements, okay, that will affect the irradiation that I told, which will cause the rapid power fluctuations. So this need to be included in the data set. If that is not included, then it will give a wrong prediction. Okay, then dust will be formed on the solar panels, smoke will be there, some snowfalls and all, then wildfires, all that scatter the sunlight, reducing the panel efficiency. Then numerical weather prediction, that is a traditional numerical weather prediction which is used to know the weather we have to forecast, right? The weather data. So weather data, how they are predicted through some empirical formula only they are predicted. Sometimes they will have some inaccuracies. Then what are the sensors you are using for for capturing the humidity or the temperature? That sensor errors also is one of the reason. Then aging, soiling, micro cracks, all that are some of the things which will affect the data sets or which will reduce the efficiency of the panel also. So these are the key challenges. Although we predict, we tell the next year this will be the output, but if there is suddenly a dust formation, suddenly there is a micro crack, the output will reduce. So when we give the data, we have to ensure that all these worst scenario conditions are taken into account. Okay. Any doubt you have? Hello. Is it all fine? Are you able to follow?
Yes, ma'am. Yes, ma'am.
Okay. Am I going fast? It's, you're able to understand, right?
No.
Yes.
Yes,
Okay.
ma'am. Yes, ma'am.
Okay. So this and that I will skip. Okay, so directly we'll go to the popular ML algorithms for energy prediction. So popular ML algorithms, first is LSTM, long short-term memory. So this is basically a time series based forecasting method, and it is available in the MATLAB toolbox. In a MATLAB has number of toolbox. I think you are aware of the software MATLAB, which is widely used in all fields of engineering. Okay, so there is a toolbox called deep learning. Under this you have LSTM. Then we can go for random forest. This is also a very popular ML algorithm, so which is available again in statistics and ML toolbox in MATLAB. And CNN, which is a deep learning based model. So it's the use case is cloud motion prediction. So from the images of the CNN is basically an image recognition technique. So you give any images, it will be able to do the predictions like a pattern recognition or face recognition. So just to capture the sky images, it will be able to give you the whether there it's a cloudy, whether the clouds are moving and all. So that it's a computer vision toolbox. I mean, computer vision model which is available in the MATLAB. Then gradient boosting, it's also one of the one of the ML method which is available in MATLAB. The function name is fit RNM. That is ensemble. Okay, ensemble method. Then reinforcement learning. Reinforcement learning is basically based on an agent-based approach. So it will learn from the observations and it will give the reward points based on which the classification or regression will happen. So it's a separate technique, like how we call the supervised learning. No, similarly, we have the another technique called reinforcement learning, which is a multi-agent based approach. So already I told you that we can go for short-term forecasting. So short-term means maybe 1 hour to 48 hours. That is 1 day to 2 days, like that we can go. Okay. So why we need short-term forecasting is grid balancing. See, short-term forecasting is also required because a major thing is you want to balance the supply and demand. So if the supply and demand is not balanced in the grid, then the frequency will be affected. Okay, so frequency will either increase or decrease, but there is always important to regulate the frequency within that. So our Indian has a frequency of 50 hertz. So you cannot go beyond say 49.5 to 50.5. That is a band. So you have to always maintain the frequency within that. So if the frequency goes beyond that band, the grid balance is lost. Okay, so that should not happen. So short-term forecasting helps for grid balancing, energy market bidding. So you have to do some here. Actually, we are following a what to say, the vertical integrated system. Okay, when you go for restructured power systems where number of players come into picture, like how we have in telecom services. In telecom services, I have Vodafone, I have Airtel, I have BSNL, I have Geo. I can use my own, whichever is comfortable. I can go for that plan. Whereas electricity, we have to rely only on the electricity board. There is no other private players. But in the future, there is a possibility. Now Reliance has come. Okay. So future there is a possibility. Okay. So, short-term forecasting is very important for the market bidding and also for ramp event prediction. That is a sudden drop which is happening due to the clouds, as I told in the previous slide. Okay, so what are the methods which is normally preferred for the short-term forecasting is LSTM, CNN, gradient boosting, which I already mentioned. And you can, since CNN is coming, you can go for sky imaging plus AI cameras. Okay, you can use AI cameras also for this short-term forecasting of the solar power output. And challenges are here rapid cloud movement will introduce high variability and it requires real-time data from IoT sensors because the forecast is only for a very short period. The data need to be more accurate. You need weather radars, you need satellites to exactly predict your weather. Otherwise, the output will be not a correct one. Okay, the prediction will not be a correct. Okay. So medium term forecasting is one which is very commonly used. Okay, it is in terms of days to weeks. Okay, so here this is required for maintenance scheduling, of course, optimizing the energy storage and the load planning. What is the load we have to plan? No, this is the output, but my load will be like this. So whether the generation is able to meet the load. Again, the same concept of grid balancing. Okay, here we can go for hybrid models. That is the numerical weather prediction model plus ML model together can be used for medium term forecasting. These are the literatures. In literatures, they have used it. Okay. Then ensemble learning, like multiple models, combination of SVM and neural network and all can be used. Okay. But the challenges are the already I told you the traditional numerical weather prediction model will have a lot of errors. So that errors in the data, a small percentage of error only, but it gets added up. Okay, so that errors will lead to some erroneous output also. So that is one of the challenge. And seasonal transitions will reduce that is like cloud movement or sudden weather shift will reduce the accuracy of the model. Then long-term forecasting, it will be in terms of years. So here you can use for financial planning, for solar plant. So when you want to do long term forecasting, when you want to do, you want to really extend that plant. Okay, you want to add another 5 kilowatts or 5 megawatts and all. So you have to do the financial planning. So you have to know what is the current plant, how much it is producing, whether it is efficient or not. So you can go for expansion. Okay, then you can also understand the climate, how the climate is going to impact, and what is the degradation, whether the plant is output day by day is increasing or degrading. All that you can understand through the long term forecasting. So here you can use statistical models or physics informed AI models. Okay, and statistical historical analysis, these are the methods which is available in the literature. Okay, I'm not going to detail discuss about this method, I'm just telling you. Okay, here the challenges are the panel efficiency declines over time. There is a possibility. Okay, see, you cannot expect, you are predicting some output based on the efficiency of the panel, but there is a depreciation which is occurring. So the depreciation will change the output or will create a different output in the real time than the predicted value. Okay, and climate change, of course, in all the three forecasting, the climate change is going to it's going to be a great challenge. So just to summarize, these are the various key methods which are used for different types of forecasting. And when you go for short term, your accuracy should be very high. 95% accuracy is expected when you use AI model for short term solar power forecasting. Medium term, your accuracy is expected to be 85 to 90 percentage, and in long term, it can be at least 80 percentage. Okay, so, and these are the key data sets. Now we are going to use one of the data set which is taken from NSRDB. UPTV data set. Okay, some of the key data sets are available already in the net. We can just take the data and you can work on it. Okay, then Open Meto API data sets, it's application program interface which covers all these input attributes like temperature, humidity, dew point, cloud cover, wind speed. All this is included in this data set. Okay, so this data set supports AI models like gradient boost for forecasting solar output. This is especially for short term power forecasting. Then you can use Serbia data set. Okay, which are all the real time data set which is taken from the solar power plant installed in Kaka. This is an industrial facility plant. These are the input variables which are available in the data set. Okay, this can be used for very short term forecasting. But the common data sets which are used, which is available in the GitHub repository, is NREL, there is a National Renewable Energy Laboratory data set, or Open PV project, Global Solar Atlas. So these are all the data sets we have taken from NSRDB in order to, for this example, no, case study we have taken from NSRDB. So these are some of the popular key data sets which can be used for solar power prediction. So this I already discussed. What are the challenges? Okay. Now I'm going to just take few models like neural network. Neural network is one of the model which I'm going to take, and I'm going to tell you how the neural network is applied and how we are going to get the output with respect to solar power forecasting. Okay. So what is a drawback of this neural network? It requires large data. Okay, so in order to avoid overfitting, that is one of the thing. Then we go for decision tree. Decision tree is basically like an if then else rule. Okay, so it will take, for example, if temperature is so and so, then check for humidity. Like that, it goes like a branch. It goes like a tree-like structure. Okay, so the tree-like structure is built based upon the data which we are feeding, and based upon the decision tree architecture. Okay, so decision tree also, it is the disadvantage or limitation is it is prone to overfitting, but the advantage is it can handle non-linear relationships much better than the neural network. Okay, and it is robust to outliers. So even suppose if there are some missing data, some noise data included, it will be able to handle that. Okay, so those data will not create any error in the output prediction. So that is the advantage of decision tree when compared to the neural network. Then next advancement of decision tree is random forest. To overcome the drawbacks of decision tree, we can go for random forest. Random forest means multiple regression trees will be there, multiple decision trees connected together. This is one, this is one. So it will take the answer. So this is mainly used for classification problems. So it will take the output, no, even for prediction we can use it. It will combine all the outputs and based on the major voting. If it is a classification, it will go for major voting. Decision tree 1 is giving label 1, decision tree 2 is giving label 1, this is giving label 0, means majority is label 1, so the output will be label 1. And if it's prediction, it will take the output of each of these regression trees and take the average. This is how it works. Okay, but it is computationally very heavier because it has number of regression trees. Hardware implementation may be little complex. Okay, but this is one of the best ML model, random forest. Next one is support vector mission, so which can be used both for classification and regression. So in support vector regression SVR model, we just built the hyperplane. This is called the optimal hyperplane. Basically, the quadratic programming optimization is involved in it. You have to solve an optimization problem and you have to arrive at this margin and all. So you have to optimally arrive at the margin. This margin is called the soft margin or hard margin. If the width is narrow, it is called hard margin. If the width is broader, it is called the soft margin. Okay, and this support vector mission, no, so whatever is acceptable with all the things within the hyperplane is tolerable, but the data points of falling out of the hyperplanes are all error data. Okay, so the advantage of SVR is it is able to handle high dimension. When you have problems with more input attributes and all, it is able to handle. But it will take more time. Training time will be more. Okay, and even with small data sets, if you are not having 1,000 or 2,000, even with we are having 200 or 300 data sets, the support vector regression will work well compared to neural network. So it is able to handle, it is able to do the prediction even with small data sets, but the limitation is the tuning of the hyperparameters. Okay, any model, ML model or AI model will have certain tuning parameters. So the tuning parameters means user defined parameters. For example, neural network means the number of hidden layers is user defined, the number of hidden neurons is user defined, so they are all the tuning parameters. So like that for support vector regression also, we have tuning parameters like kernel parameter. Kernel is actually a function which is used. Okay, so I'm not describing detail about SVR. Okay, I'm just giving you the keywords. Okay, then C is the penalty parameter. Okay, normally we use a penalty parameter because if you don't use this, then this hyperplane cannot be built because many of the data points will be lying outside the hyperplane. So you have to use some penalty parameter to fix the hyperplane. Then epsilon is a tolerance value. Okay, so you have to properly select these hyperparameters. For that, we are having the conventional method called cross validation. What is cross validation is we will take different values for this hyperparameters and we will find the classification accuracy. There is a cross validation matrix. In that matrix, you will be evaluating kernel is, for example, my kernel parameter is this one, C is this one, epsilon is this one, find the accuracy. Like that, we will take different variants. And from that, by trial and error, after doing that, we will select this is the best one which gives the maximum accuracy. That is called cross validation approach. Okay, for selection of the hyperparameters. That is the conventional method. You can even use genetic algorithm, particle swarm optimization, such meta heuristic algorithms also you can use to select optimal values of these hyperparameters. And Gaussian process, this is also one of the ML model. This is not much used, but for certain applications we can use it. This is purely based on the probability distribution. That is a Bayesian model, Navy based model. This is one of the conventional ML model. So any model, no, they will try to compare with the Gaussian process or the Navy based model. So why it is good for the prediction more than classification? It is good for prediction because it is able to handle the uncertainty. So the data is highly uncertain. No? It can handle the uncertainty. It is flexible. It is able to capture the complex patterns. It works well like SVR. It works well for even small and noisy data sets. But the disadvantage is it's computationally expensive. It's computationally very heavier. Okay, order of n power 3. The number of attributes you are using. If you are using 10 attributes, then 10 power 3, 30 times it is computationally expensive. So that is why it is not that much preferred. Okay, just I'm giving you the important ML models which are frequently used for various applications. So these are the models which I'll be using for my solar also. And in solar we are not doing classification, we are only doing prediction. So prediction metrics, no performance metrics, any model you have to evaluate whether it is working fine or not. So you need some performance metrics. So there are some performance metrics like root mean squared error. This is the formula for root mean squared error. I think you are familiar with. I don't want to explain it. Okay. Generally, this value should be less. Then only the model is fine. Error means it should be less, right? So if there are large errors, then it will be penalized more heavily. Okay, there is if you are having a lot of outliers, because in the data there may be a lot of noise, a lot of outliers which is not removed. So if such is the case, then the root mean square error will be very high. Okay, so we have to ensure that the data is cleaned properly such that the model will work fine and the RMSE will be less. Then mean absolute error. So this is the value. So mean absolute means you are taking the error. Error is actual minus predicted. Okay. Then you are taking the mean value. 1 by n sigma is called the mean value. So this is called the mean absolute error. Then mean absolute percentage error. It is the same as this. The only thing is you are making it as a percentage, that is 100%. So all these three should be very low. Then there is another important performance metric called R square. So it basically represents the variation, the proposition of the variance in the dependent variable as per the trained by the model. Okay. So generally, if it is closer to one, the model is best. So the more closer to one, the more best is the model that is being constructed. And how to evaluate R squared? This is the formula which is used to evaluate the R squared. Okay. So this is yi minus yi prime. This is the mean of that value. So we are taking the, this is a reference. Yi is actually the predicted value minus the average. Y bar is nothing but average of all the outputs. Okay, hope you understand this. So it can be negative if the model performs worse than a horizontal line. So R squared should never be negative because this value should be always less than 1. If this value is greater than 1, then the model is performing very, very worst. Okay, so that is what is the indication. So for any regression application, you have to evaluate these parameters and identify it. Okay, so RMSE should be close to 0, R squared should be close to 1, MAE should be close to 0, and MAPE should also be close to 0%. This is what is the best values. Now we will go for MATLAB simulation. Directly, I will go into the MATLAB simulation part. Okay, and this is basically the algorithm. Okay, so before going into the MATLAB simulation, I will show the algorithm. First, you have to collect the data, do the data pre-processing, split the data into training and testing set, then train the model, and finally evaluate the model. And once the model is evaluated, and if you feel that the model is working fine, you can put it for real-time implementation. So here you can see during the training process, if the training goal is met, what is meant by training goal? That is a root mean squared error. We will mention that the root mean squared error should be less than the tolerance, 0.001 or 10 power minus 5. So if it is less than that, the training goal is met, then the testing will be, the model will be given to the testing. Else, the model will be continuously subjected to iterations with parameters retuning and cross validation, keeps on updating. Okay, the model gets trained and trained and trained. Okay, now we will go for MATLAB simulation. One minute. My God. It takes more time. So this is an online MATLAB platform, so it is taking more time. Oh, just hold on for a minute.
Okay, ma'am.
Yeah. Do you have any doubts up to now?
Participants getting doubts for I'm question in chat box, ma'am.
Yeah, tell me.
What we have to do for increasing efficiency of solar power generation?
Increasing the efficiency of solar power generation, one thing is you can use bifacial panels. Nowadays we have panels with different models. Okay, we photo initially we are using this one polycrystalline, then we moved to monocrystalline that was having a better efficiency. Now people are using bifacial, especially for industry applications. When you have a large solar farm in the order of megawatts, bifacial means it is two back-to-back panels. So top also you'll be absorbing the sunlight, bottom also direct radiation will be there, diffuse radiation will be there. That is one method, and you can go for tracking panels. Okay, that is also one of the method, and floating solar panels which were laying on the river beds. Those are all some of the techniques which can help to improve the solar panel efficiency. And if you are using a standalone PV system that is not connected to the grid, the battery plays a vital role. Okay, solar output, that is, the solar output is used to charge the battery through the charge controller. So in standalone system, the battery will be continuously supplying to the load. Okay, so we are using only lead acid batteries, right? Now people are thinking to use even lithium ion batteries for solar PV applications. Is it okay, sir? Are you convinced with my answer?
Thank you. Thank you.
Yeah. I don't know why it is taking so much time. Oh my god. Okay. In the meantime, let it get open. We will play a quiz. Okay. So I think the net is a problem.
Participants, we will have a quiz. Ma'am will send the link now.
Am I audible, sir?
Yes, audible. Prakash, sir.
I'm having a small question.
Yes,
Yeah.
sir.
Yes, sir.
See, uh, apart from tsunami or thunderstorm, how wind pressure and wind direction affects solar power generation? That is my question.
No, here, actually, if you see, this is a real case which has happened when I was working in an institution because of heavy wind
Okay.
flow. Okay, because that was mounted in the terrace of fourth floor. Okay, so if you go high and high, you can experience wind flow will be much higher, right? Wind pressure will be much higher. So actually, the panel itself was dismantled. Actually, it took off out from the mounting structure. Such a
Mm,
heavy wind flow was there. Okay,
mm,
so when there is a wind flow, what happens is it cannot focus. The panel cannot focus towards the direction of the sunlight,
mm.
right? So
Oh,
it's very simple. For example, if we are moving in a cycle, if we are driving a cycle, if there
mm,
is a heavy wind flow, what we do, we apply more pressure, then only
mm,
we can move against the air. So it's a air drag force, right? In EV also we talk about air drag force. So that is, of course, it doesn't have a major impact like solar irradiation, but it is creating a effect. It is having some effect. Wind pressure as well as wind direction.
I think, sir, madam, if there is a wind, it will give cooling to the panel, so it should increase the efficiency. Is it not?
No, cooling to the panel. Okay,
Because
you are telling.
panels are getting hot, and if there is a wind flow is there, it may cool down. So the efficiency of solar panels should increase. That is what I guess. I may be wrong.
No, no, it is not that way. It is not that way. Cooling means actually it depends upon the temperature,
Oh,
not about the wind. And another important point in solar is lesser the temperature, more the output. Okay,
acha,
so when
acha.
yeah,
Much,
irradiation should be
then cooling
higher.
will definitely come.
Yes, higher the irradiation, higher is the output. That is well known. But
Okay.
temperature, if you see, if you have 30 degree, 40 degree, or 50 degree, the solar power output will be affected. Only if
Acha.
you have less temperature, output will be high. You can understand that from the
Yes.
PV characteristics. You go and take the data sheet of any solar PV model. If you see the data sheet, you will be able to see that the graph. From the graph, you will be able to predict that higher temperature leads to lower output. That is, solar power output will decrease. So that is how we understand. Okay.
Thank you, ma'am. Thank you.
So I don't know. There is a problem in net. Everything is taking 1 minute. This is also not coming.
You can go for quiz, ma'am.
Yeah, quiz only. So it's not opening for me. The problem is that we are in home, right? If in office means no problem.
Yes, ma'am.
1 minute.
Good evening, ma'am.
Yeah.
Yeah, ma'am, this is Malati, Dr. Malati from Chennai Institute of Technology, ma'am.
Yeah. Tell me, ma'am.
What challenges we may face in developing AI-enabled based battery management system for the solar grid integration, ma'am?
So
In which area we can focus for research, ma'am?
okay. So first is battery management system. If you see, for solar, there is no battery management system at all. Okay. So only for EV applications, you have BMS. Because when we go for lead acid batteries, it is not required to monitor the voltage and temperature and all. Only in lithium ion batteries only we have to take more precaution measures. Okay. So first you have to see whether there is a battery management system in solar PV forecasting. Nowadays, whether to my knowledge there is no BMS. Okay. So first you please clarify that aspect. Maybe nowadays the new models are having. Okay, so first you clarify on that aspect. And if at all, if you want to do A applications, you can go for state of charge estimation, state of health estimation. Whether my voice is clear?
Yes, ma'am.
Okay. Now I know suddenly I got some echo.
No, ma'am.
So
It's
these are
clear.
the areas which you can work on. Okay, state of charge and state of health. Okay, so state of charge, especially we have to monitor the state of charge. Nowadays, we are having only the conventional empirical methods. You can go for data-driven models like AI. Even my own research scholar, no, Dr. Pushpanam, who coordinates this session, he has worked only on SOC estimation using AI model. So that is for electric vehicle applications. Okay. So first you be clear whether you want to work for solar power applications or EV applications. Okay. Accordingly, you have to decide.
Good evening, madam.
Yeah.
I'm researcher, madam. I am concentrating on V2G technology. Can you hear my
You
voice,
can put
madam?
forth your
Yes,
question.
sir. Yes, sir.
In V2G technology, to maintain the grid stability by the using AI application, reinforcement learning has been implemented. How it is possible and how we can apply the reinforcement technique in the grid side to meet out the stability and resilience.
Reinforcement learning is applied. I could not get your question, sir. Can you repeat?
In vehicle to grid, I'm
Oh,
concentrating
okay.
on the
V2G technology. Okay.
V2G technology. To meet out the grid stability and resilience, we need to apply the reinforcement technique. That thing I will be knowing, but how it is possible and what are the stability and efficiency has been maintained while applying the reinforcement technique.
So first thing is frequency regulation and voltage support is required. Voltage regulation when you go for V2G technology, because now we are not facing much problem. When more number of EVs are coming, the at the same time the charge, all the EVs will be charging. Okay, so the
Yes.
overall load on the grid is going to increase. The grid is going to get overloaded. So when the grid is going to get overloaded, automatically the frequency is going to dip. Okay, so you have to understand the frequency should be maintained. All we are not going for DC loads. Still, we are with AC loads only. Okay, so the grid has to give the, I mean, service to the other normal. Normal loads, whatever it has been already supplying also. Okay, so there the problem comes, and the major issue still lot of research is going on stability aspects, and especially handling reactive power. Okay,
Yes, yes.
the reactive power balance handling is an important thing with respect to grid stability issues. That is where we talk about voltage stability. There are two stabilities, right? We don't have anything like rotor angle stability in that case. Because rotor angle stability pertains to thermal power plant where synchronous generators are there. So here we have to focus more on frequency stability and voltage stability. So those are the things which we need to focus on.
Reactive power in the sense generating the power from outsource.
No, reactive power balance has to be met. That is how much amount of reactive power is generated, that much amount should be consumed. Reactive power is an important thing. You cannot have system without reactive power. It is very, very easy to understand, sir. For example, you are having ice cream. Okay, you are eating ice cream. On the top, you are having some things, right? Cherry fruits and all. So if you see that, you feel like eating, right? But the main part is ice cream, right? Right. So the useful power is your active power, real power. But
Okay.
reactive power supports for the system, energizes the system. But at the same time, the reactive power, how much power is generated, it should be consumed. That is very important.
Okay.
Okay. So you have to balance your
Participants,
reactors and
join
all.
the
You can,
quiz.
yeah, you can join the quiz by
Go to
scanning
the
the.
joinmyquiz.com or scan the scanner and type the number 711907.
Still, MATLAB is not coming. I'll just. So you can quickly join the quiz.
Yes, participants, join the quiz and enter the code 711. Ma'am, can you 907? The
Let's
code is
see.
711907. Go to joinmyquiz.com.
Oh, somebody has given the PIN number itself as a name. Yeah, now it is opening.
Participants, kindly join the quiz. Go to joinmyquiz.com and enter the code 711907.
Let them parallelly join. I will demo this model. Okay.
Okay, ma'am.
So just 2 minutes. So here, if you see, I have a plant generation data and weather sensor data. Weather sensor data, there are some 6,000 samples, I think. If I want, I can show you Excel sheet. So this is the weather sensor data with this date and time. This is the real time data. Date and time is shown, plant ID is shown, okay, and then source is shown. From the source key means the parent key, Then ambient temperature, module temperature, irradiation. These are the three parameters. Okay, these are the input parameters. Then output parameters is your generation data, which is basically the yield AC, that is the DC power which is coming from the solar panel, AC power which is coming from the inverter, then daily yield and total yield. Okay, so I'm taking only the daily yield for the prediction, not the total yield. Total yield is the cumulative yield. CSV file which is taken from your real-time plant. Okay, we have also published this in a conference. Okay, let me close this. Okay, now if you see the MATLAB program, okay, so this is basic PV program just to see how the PV power output is varying. Okay, how many participants? Only 20 have 65.
65, ma'am.
Okay, net is
Participants
slow.
join the quiz. Go to the website joinmyquiz.com and enter the code 711907. Ma'am, just go to the Google it,
Quiz.
ma'am. Joinmyquiz.com. Otherwise, you can scan the code, ma'am. Scan the code and enter the value 711907.
Blank means
Name.
it will not ask a PIN number. Directly
Okay,
they
ma'am.
have to give. So this is just the solar power output for the data which I have given. Okay. No, not for the data. This is a data which is curated through a model. I mean, just creating a panel of 330 watts panel. Okay, and number of series connections. 10 panels are in series, 20 are in parallel. Like that, we are creating. Then for that, we are giving some inverter efficiency and derating factor, and based on that, we are just giving an empirical formula for temperature. This is just there is a model which is created through empirical formula, not the real time data. So this is how the solar power output varies. Just to show you, during daytime there is no during the early morning there is no output. After 6 o'clock the output is there. Then after 18, that is 18 hours, 6 p.m. there is no output. Okay.
Hello, sorry, Dr. P.K. Chidambaram interrupting. A question, the quiz I just joined, not 8 question is there, but I cannot able to see question.
No, still I am not.
Sir, ma'am, I have to start, sir.
Oh, not at
That's
start.
why.
Yeah, I joined there.
Yes, sir.
Only
Yes.
they are showing
Okay.
8 questions. There is no
Okay,
question.
sir. Okay, sir. Okay.
Okay, we'll wait.
Ma'am, can we start, ma'am?
Yeah, I will
Okay.
start. I'll
Okay.
start in the
Okay.
intermediate also. They can join. I will start the quiz.
Yeah, thank you.
First question: which of the following best defines artificial intelligence? So for every question, you will have 30 seconds. You have to click the collect answer color, the color box. No, you have to click it. It will come in your mobile. So what will be the answer for this?
Option A, ma'am.
Pula David. Yeah, good. Pula David is actually coming topper. Option, fourth option. It's not use of the algorithms. It is the simulation of human intelligence processed by machines. That is the actual one. Okay. So I think you have to answer quickly. Others, only 39 have answered. Machine learning is a subset of AI that focuses on
Machine learning subset of AI focus on design and order, creation of static rule data processing. Static rules and data processing.
Sir, can you mute, sir?
Yeah.
no issues.
You're giving only giving only 30 seconds. No, I have to figure out. Okay, I will do it.
Okay, and no issues, sir. See, it's all like we are all mature, right? So if students know, they will immediately put Google Lens and they will scan it. Okay, the answer is development of algorithms that allow computers to learn from and make predictions. Hope you understand that answer. Okay. Which of the following is an example of supervised learning? So the answer is, yeah, predicting whether an email is spam or not. This is only an example of supervised. This is second is unsupervised. First one is clustering. Okay, finding patterns in stock price without supervision is also unsupervised. In solar energy forecasting, the target variable in a regression model is usually, okay, Tula David, Madam. Okay, good. So the answer is solar energy production, not solar panel efficiency. Panel efficiency depends upon,
Hello, ma'am.
extremely.
Hello, ma'am.
No, no, I got connected again. Sorry, extremely sorry.
Okay, ma'am. No problem. Okay, next question, ma'am.
Yeah, it's running. Let me. My goodness, I'll put it in hotspot.
Hello, ma'am.
Yeah,
I am giving right answer, but it is showing incorrect.
how?
The last one and the previous two also.
Please hold on for a minute. Let me see. Internet is a big problem. So here, this is what is the algorithm which I want to tell you. Okay. So if you take, I'm reading the plant generation data and weather data, then converting the date time format, because it is, I have to convert into numerical format for merging. Then based on the date and time, this input data and output data, they are joined. So using join, no, I'm joining it. Then after that, I am removing the outliers, like wherever the zero irradiation is there, like night time and all, I am removing it, so that unnecessarily I should not use the data because output is already zero. Then after that, I am merging the input data, that is ambient temperature, module temperature, irradiation. Those are called features. Target is the AC power. Okay.
Ma'am,
Now
screen is
I
not shared, ma'am.
screen is not shared. Oh my God.
Yes, ma'am.
Problem. This is a problem with online sessions. We don't know what is happening.
Yes, ma'am.
Okay. So this is the program which I wanted to tell you. So reading the data, okay, the generation data, weather data, then merging the data based on date and time. Date and time is the common thing. Okay, the sensor has captured. Then taking the input features as ambient temperature, module temperature, and irradiation. Output is AC power. Okay. Then X is the input, Y is the output. Okay. Then splitting the data, training and testing data, and then finally using the regression model, this decision tree model, to I mean, first we are training the model, building the tree structure, then predicting the model using predictive function, then finally we are evaluating the error. Okay. So this is what happens. Okay. This is for a single model. Suppose if you have multiple uh, algorithms. So here in this program, the same program, I have used multiple algorithms. Regression tree, random forest, regression tree fit R tree is the built-in function in MATLAB. Random forest fit R ensemble, SVR fit R SVM, because all are regression, so RR will come. Gaussian process fit RGP, fit RNet, because the same algorithm can be used for classification also. So regression means you have to use that R. Okay, the function name is fit R. So after this, I'm just evaluating all the metrics. Okay, for each and every method, random forest, regression tree, I'm using for loop. For I equal to 1 means first technique. I equal to 2 means the second technique. Like that it will take. And it will train the function, it will predict the model, evaluate the errors, and plot it. That is what is happening. I'll just run this. Okay, nothing else big in it. Okay. So here you can see first it is training with the regression tree. These are the values. Then it is training with a random forest. Then support vector regression. Then Gaussian process. So it is taking some time. So finally, neural network. Then it will show the output also in the form of bar chart so that we can see the comparisons. So since the net is slow, it is taking more time. Okay. Yeah, this has come. Sorry, I'm making you to switch between this and this. The
No
next question
problem.
is come. Which input feature is most relevant?
Participants, next question has come.
Thank you. So the answer is which input feature is most relevant? Irradiation. Okay.
But
What's the
answer
main
is sounding
advantage of
wrong, ma'am.
using AI based solar forecasting over traditional methods? Sixth question. So the answer is increased accuracy. If you use AI, you can get better accuracy in energy prediction rather than traditional methods. What does training a machine learning model mean in a solar forecasting? This is an easy question.
Voice not audible.
It is not moving.
It's final question.
So the answer is the last one. Okay. Training the model means teaching to recognize patterns in historical solar data. This is the last question. Which of the following data sets is most commonly used in solar forecasting models? So it is the historical solar irradiation data. Let us see the scoreboard. So appreciations to the winners. Kundru, I don't know if it's madam or sir. Then second place Govindan sir and then Dr. D. Beulah David. Congratulations. And the runners are Mahi and Dr. K. Arul Jayaraj. Appreciations to the winners. So this is the actual thing which I wanted to show you in MATLAB. Okay. It will also give the output in the form of graph. You can see that. Any doubts you have? So I just illustrated the introduction to basic AI/ML and then what is solar power forecasting, how AI is related to solar power forecasting, and finally we have discussed about the short term, medium term, long term, what are the various ML models which are widely preferred, and finally the MATLAB simulation part. taking an example of the data sets, the real-time data sets. Oh, why the plot is not coming? The plot. Plot is not coming in. Okay, I will show you the plot in the PPT.
Okay, ma'am.
So this is actually the plot. Okay. So you can see that black color is the actual output of the solar based upon the data. So here we are having some 6,000 samples, but I have not given the plot for all the samples, just 100 samples randomly I've taken. Okay. And I've given the actual value which is in black color. The others dotted lines are all different algorithms. Regression tree, random forest, SVR, Gaussian process neural network. So more or less they are matching. Okay, so among all the five models, the random forest and regression tree is having a better performance in terms of high R squared. Okay, so this is what is the thing. Okay, so here, R squared score, if you see, random forest and regression is having better. So they are having a better performance when compared to the other algorithms for this data set. So any doubts you have in this?
No, ma'am.
Participants, did you feel the session to be useful?
Yes, ma'am. The comments are coming in chat box,
Okay.
ma'am.
So if they have any, if they are doing any research, any help, you can very well give my mail ID. They can mail to me and they can get my help because I worked in many algorithms. Just a few one day I have told you because the time is limited. Okay. If you want to any help related to your project or research work, I am always open. Okay. So thank you for giving this wonderful opportunity. So amidst the evening time, no, beyond 9 o'clock, I have taken almost 15 minutes I have consumed. So thank you very much for your
It's okay,
patience.
ma'am. Thank you.
Okay.
Thank you so much, ma'am. Usman, sir.
Thank you, ma'am. Thank you for the clear
Thank you. Thank you
Kindly
all.
share your mail ID, madam.
Ma'am, can you share my mail?
I can leave the meeting, right?
Yes, ma'am.
Thank you, ma'am.
Thank you, sir. Thank you.
Thank you for well informative online presentation. Session was highly engaging and enhanced our understanding of the topic.
Participants,
Thank
kindly
you so
fill the
much, ma'am.
feedback posted in chat box. Thank you.